Welcome back. In this section, we'll discuss several analytics strategies, which starts from asking an appropriate question. If you still remember, in the section of empirical inquiry, we learned how to make use of a research design matrix to enable empirical inquiry. Let us bring the knowledge of empirical inquiry to this section. Generally, the process of analysis involves four stages: frame, assemble, calculate, and share. Relating empirical inquiry, we perform the first stage, framing our analytics problems. In this stage, we identify clearly what are our business problems or what are the issues that we want to solve. Once our issues or problems are clear, we enter the second stage, assemble. Here, all available required data are determined and collected. Some pre-processing may be needed if the data is not clean enough. For this basic course, we just assume that all our data are ready to use for the next step, which is calculate. This step is sometimes regarded as the modeling step, where we need to model the outcome inductively or deductively, where most of the time we'll make use of various statistical models. Eventually, after getting our findings and outcomes, we share with our coworkers or clients. In this section, let us focus on the first stage, framing the appropriate problems for data analytics. Here, let me introduce 6 main types of analytics questions. First, descriptive question. Relatively, this question is the easiest to answer, as we only need to quantitatively describe or summarize the main features of the data that we have collected, or we will collect. To effectively describe the data, visualization skills can be made use of. Charts can be drawn to illustrate information like frequencies. Also, descriptive statistics such as average, mode, median, standard deviation, skewness, and etc. can be included. An example of descriptive question is, how many customers visited the store last week? Using a frequency table or a bar chart, we can easily answer this question. Another example is, what is the average number of books read by Malaysian teenagers? To answer this question, we'll just need to do a survey on sample of Malaysian teenagers and calculate based on the responses. The next kind of analytics questions is exploratory question. This question aims to analyze data in order to discover connections, patterns, trends, and etc. between variables. For example, we may want to know what is the distribution of customers who bought the breakfast pack on their way to work as compared to customers who bought the breakfast pack not on their way to work. We may see some interesting patterns that were comparison are done. Another example is, what is the distribution of teenagers who read books as grouped by their parents' education level? To answer the exploratory question, we can also use data visualization by plotting the variables of interest side by side and compare. The third kind of analytics questions is inferential question. Another term for inferential question is hypothesis testing, which means that we are interested to find out general facts on a population based on samples. For example, we may assume that female customers are more likely to buy breakfast packs as compared to male customers. However, sometimes we are not able to extend this study to the whole population of customers. Therefore, we may need to select random samples and carry out hypothesis testing to check whether our assumption is accepted. Another example is, we may want to check whether teenagers who have highly educated parents read more books. But we can't survey all teenagers. Therefore, samples are selected and estimation can be done from there. Next, another analytic question is predictive question. Here, we analyze current or live or the historical data, then find out trends and make prediction about future trends. For example, which weekday in a week that most customers would buy the breakfast pack? We may find out that on every Monday, the sales are higher than all other days in a week. Or we may be interested to find out whether the number of teenagers who like reading will increase in the coming year. To answer predictive questions, more analysis and modeling need to be carried out in order to get more accurate predictions. Getting into more complicated situations and to get more insights, harder questions may need to be asked. Let us look at causal questions. As the name suggests, we are interested to find out the cause and effect. A common way of doing it is we see what happened to a variable when we change another. A lot of time, correlation does not mean causation. For example, let's say a group of students need to undergo 2 tests. We may find out that students who perform well in the first test are more likely to perform as well in the second test, and vice versa. In this situation, we say that the first test is positively correlated to the second test. But can we say that the result of the first test causes the result of the second test? We can't. The real factors affecting the students' results are something else, such as the number of hours they are studying for the test preparation. Therefore, we need to be extra cautious when testing what are the causal relationship between variables. An example question is, will customers who normally buy breakfast packs on their way to work still buy it on their rest days? Here, we are trying to see whether working or not will cause a customer's tendency in buying the breakfast pack. Another example is, will the number of reading hours drop if teenagers surf the internet more? Here, we are trying to see if hours of surfing the internet influences teenagers' reading habit. Lastly, let's look at the mechanistic question. Among the 6 types of questions introduced here, this is relatively harder than the rest because we want to try understanding the exact changes in variables that lead to changes in other variables. You may find it similar to causal questions, but mechanistic questions involve drilling down to how the factor influences a variable. For example, how does working increase the probability of customers buying breakfast packs? Or how does internet surfing influences teenagers' habits of reading? Now, let us look at a use case and get introduced to framing data analytics problems. The use case given here is credit card fraud. I just encountered this recently. A few months ago, after dinner, I received an SMS from my credit card provider saying that they have frozen my credit card as there are a few consecutive suspicious transactions. It turned out that the bank was correct. Those transactions were not made by me. You see how clever the bank was. Let's try to frame what the bank has worked on. The bank needs to be able to identify problems in order to outline abnormal activities across customers and usage. Then, they assemble the data and calculate to get reviews about abnormal activities. Lastly, they share their outcomes by establishing fraud detection optimization. Here, let us focus on the first part first, framing the problem. We may look at the problem from 4 angles: changes in transactions, structuring in transactions, geography, and involved parties. To identify changes in transactions, we may ask several questions such as: is there any significant changes from the previous average activities? Is there any different peak transaction noticed? Is there any unusual types of transactions as compared to the past transactions? And etc. To identify abnormalities in the transaction structuring, the bank may look at whether they are avoidance of threshold reporting, rapid movements of funds, or any unusual structures in terms of deposits, withdrawals, and balance. Furthermore, geographical issues can be taken into consideration too. For example, the bank may pay more attention on high-risk areas. Or, it is suspicious as well if a credit card is used in a new location. Abnormalities can be related to any app location or customer's address also. The bank can also analyze by looking at the involved parties. For example, is there any specific patterns or how funds are transferred between customers and other entities? Is there any recurring patterns? Or is there any sudden appearance of originators or beneficiaries? Till here, I hope that the contents that I shared give you more insights about what is framing problems for data analytics. There's an assignment on this topic for you. Let's go and try it out. Do let me know if you need any guidance. All the best!